Hi everyone, this is Dr. Orkun Baycek, and today we are going to talk about simple linear regression models. So let's get started. So the regression models are usually used for two purposes. The first one is to understand the relationship between different variables or different factors. Okay, so first of all, we want to understand the relationships. And the second purpose is to predict the value of a variable based on another variable or another factor. Okay, so we first want to understand the relationships, and also we want to predict the future values. There are two terms that we need to know when it comes to regression models. The first one is the response variable. So the variable that we want to predict is called the response variable. Okay, so whatever we are trying to predict, that is the response variable. And the variables or factors that we use to predict the response variable is called a predictor. Okay, so predictor is what we use to predict the response variable. Okay, so let's get into a numerical example. So I have this data set here which shows a sample of 15 employees that work for a company, and in this company, in this data set, I listed the number of years of work experience and the annual salary of these employees. Okay, so the first employee, for example, has 4 years of work experience and is making $70,000 per year, and the second employee has 8 years of work experience and is making $108,000, and so on. Okay, so the first question that we will need to answer is to create a regression model that could be used to predict the salary based on the number of years of experience. Okay, so this sentence, this question clearly tells me what is the predictor and what is the response variable. Okay, so since this is a simple linear regression model, I have one predictor and I have one response variable. If we were to talk about a multiple linear regression model, which we will in the next videos, then we have multiple predictors and one response variable, for example. All right. So in this case, what I'm going to do is I'm going to first identify what is the predictor and what is the response variable, and then I'm going to use the data analysis Toolpak to create this regression model. Okay. So first of all, the question says use the number of years, based on the number of years of experience, we want to predict the salary. So we are going to use the number of years of experience to predict the salary. So in this case, the predictor is the number of years of experience because that's what I use to predict salary. So the salary is then my response variable. Okay, so this will be important when it comes to putting this into my regression menu. So to be able to create a regression model, what I'm going to do is to go to Data tab, and you should be seeing this data analysis option here. If not, what you need to do on a Mac is to go to Tools at the very top here and Excel add-ins, and then you need to make sure that this Analysis Toolpak option is checked. If not, make sure you check it and then say OK, and in most cases you will need to close Excel and restart it to make sure that Data Analysis Toolpak shows up on your menu. All right, so I'm going to go to Data Analysis and I'm going to find Regression option here, and I'm going to say OK. All right, so I'm going to see this menu, and it's fairly simple to fill out. First of all, it asks me to put the input Y range, which means that Excel is asking me to provide the response variable. My response variable is the annual salary, so I'm going to select the response variable values. Input X range is the predictor. All right, so the predictor values are these values. So I inputted those values here. Confidence level is by default 95%, so I'm going to use 95% in this case. And next, you are going to select where you want to see your results, okay? You can choose to create a new worksheet and send your results to that worksheet, but I usually like to see the results on the same spreadsheet if I have enough space, okay? So what I'm gonna do is to select output range, and then anywhere empty works, so I'm going to select F1 here, and then I'm going to say okay, and then here is my result. So there are various numbers here that we will use, and based on the questions, we will be able to identify which ones are the ones we need. So question part A is asking us to create a regression model, and I can look at this table and create my regression model. So the important components will be these two values here. So that is going to give me the regression model that I am looking for, okay? So my regression model will look something like this: 42, 53, 1699 plus 14, 747, 675 x. Okay? So basically what I did is I took the intercept from this table, plus I took the x value, the coefficient of x, which is 14,747.675 multiplied by x. This is my regression model. Okay, so this is the answer to part A. All right. Part B, select these to make sure they all go to the right. All right, so part B, predict the salary of an employee who has 9 years of work experience. Okay, this question is asking us to make a prediction using our regression model from part A. Since we are using the number of years of work experience to predict the salary, I can plug in 9 instead of x here and just solve this to make sure to be able to find the annual salary for 9 years of work experience. So what I'm going to do is I'm going to select the intercept plus the coefficient of x times 9, okay? Because I'm looking at 9 years of work experience, so I plug in 9 and the result is the salary. So $136,982.25 dollars. Okay, so this is the forecasted salary. Part C, give the values of R and R squared for your regression model. So there are different ways to ask the same question, and we are going to see it in the next couple of parts of this question. But it's essentially asking me to provide the correlation coefficient and the R squared value. From my table, if I look at this part, this value, the multiple R, is my correlation coefficient. So R is 0.888, and R squared is equal to 0.788. Okay, so R squared is given in this cell and R is given in this cell. So multiple R corresponds to R. R squared is here already. Okay. Part D. In part D, the question is asking us to provide the correlation coefficient. Correlation coefficient is the same as multiple R. So the answer to this question is also 0.88. Okay, so R and correlation coefficient are the same. So the answer is 0.888. Part E. The question is asking us to plot a scatter diagram to verify the answer from part D. So the correlation coefficient in part D tells us that there's a positive relationship. We can even say that this is a strong positive relationship because this value is close to 1. Okay, remember correlation coefficient, if it is close to 1, we say that it's strong positive, and if it is close to -1, we say that it's strong negative. Okay, if it is greater than 0, it's a positive relationship. If it is below 0, then it's a negative relationship. So we are going to plot a scatter diagram to verify our answer from part D. So to plot the scatter diagram, I'm going to select both of these, the predictor and the response variable. And then I'm going to go to insert, and then you are going to see this option at the bottom, XY scatter. And if you click on it, the first one is what we are interested in, scatter. And that will provide me my scatter diagram. So I'll just drag it over here. And then the chart title, let's change it to scatter diagram. So the next step is to right click on one of these dots and select add trend line. Okay, so with this trend line, what I am seeing here is that, as you can see, as the number of years of experience increases, I can see that the salary also increases, so there's a positive relationship here. So if you see a pattern like this, then you can say that there's a positive relationship. So this verifies my answer from part D because I am seeing a positive relationship in this graph. All right. Part F. So how much of the variability in employee salary can be explained by your regression model? Okay. This is the same question as asking us what is the R-square value. Okay, so R-square is what we use to explain the variability. Okay, so when the question asks you how much of the variability can be explained by your regression model, your answer is to provide the R-square value. So the R-square we already know from our table. That value is 0.788. Okay, so you can provide the full value if you want, but 3 decimals will also work. But you can provide the whole value if you're interested in doing it that way. All right. Part G, is your regression model statistically significant? Okay, so it's asking me if my regression model itself is significant. To be able to answer that question, I will need 2 values, okay? The first one is the alpha value. And the second value is the p-value. So alpha value, if you remember, when we worked on this regression menu, the confidence level was by default 95%. If my confidence level is 95%, the alpha value is going to become 0.05. Okay, so basically the confidence level is 0.95 and alpha value is equal to 1 minus 0.95. In our case, alpha is equal to 0.05. And the p-value is something we identify by looking at our result. And our p-value is given in this cell under significance F. Okay? The value in this cell is a very small value, and to verify this, what you can do is you can copy that value and paste it on an empty cell, and then right click on your mouse and select format cells, and then on the menu, if you go on number and increase the decimal places, you are going to see that the number here is a very small number. So for example, if we have 13 decimal places, if you say OK, you are going to see that this value is actually a very small value. Okay, so when you see a format like this, and if you're unsure about if this is a small value or large value, what you can do is to right click on it, format cells, and then go to number and increase cells. To see that it's actually a very small value, okay? decimal. Okay, so it has a lot of zeros after the decimal point. Therefore, this is a very small value, and it's definitely smaller than 0.05. So my p-value is this one. And in this case, to be able to answer this question, all I need to check is the p-value smaller than my alpha value? If so, then I'm going to conclude that the model is statistically significant. And in our case, since p-value is smaller than alpha, we conclude that the model is statistically significant. All right. So again, since the p-value, let me fix that. Since the p-value is smaller than alpha in this case, we conclude that the model is statistically significant. If the p-value was greater than 0.05, then we would say the model is not statistically significant. Okay, so be careful with this significance f value, because usually students get confused with this, that it seems like a real large value, whereas it is a very small value because of this last part of the value. Therefore, you need to be careful with that to make sure that you identify the correct value. And in this case, it is smaller than 0.05, which is my alpha. Therefore, the model is statistically significant. Okay? So thank you so much for watching this video, and I will see you in the next one.